Insulated copper cables can... By 1997, the skyline of Kuala Lumpur will take on an impressive addition as Phase 1 of the Kuala Lumpur city centre development takes shape. Distinctively etched against the skyline will be the Petronas Twin Towers. At 450 meters high, the 88-story Petronas Twin Towers will display a unique silhouette of two gleaming pinnacles and will be visible from any point within a 20-kilometer radius. The towers will be linked at the 41st and 42nd floors by a distinctive two-level skybridge, 170 meters above ground. The 41st and 42nd floors are also the sky lobby area that divides the function of each tower into two. The skybridge serves as a functional feature of the Petronas Twin Towers in terms of providing a link between the sky lobbies of each tower. This enables occupants to conveniently move from one tower to the other by crossing the bridge at sky lobby levels without having to go all the way to the ground floor lobby. The skybridge is also vital in an emergency evacuation, where occupants can use the bridge and have the choice of using 4 sets of exit stairs rather than the 2 available in one tower. Lastly, the skybridge also allows sharing of facilities, such as the conference center and executive dining room. In design, the skybridge is a conventional 2-span continuous girder bridge. The engineering consultants, Ranil Versakutu Sindhir and Brihad, in association with Thornton Tomasetti engineers, designed the bridge using state-of-the-art computer simulations, which was followed by wind tunnel testing by RWDI of Canada.
Now in this case we've got two very tall buildings beside each other. So the effect of the wind and the wake on one tower may be affecting the loads on the second tower.
Green's firm, Roland Williams, Davies and Irwin of Guelph, Ontario, has done similar studies on designs for some of the world's highest profile projects.
As the wind tunnel tests indicated vibrations to the legs, 2 mass dampers were placed inside the legs, and these dampers reduce vibrations from unusual wind conditions and possible long-term fatigue due to the resonance of the legs. The 2-hinge arch supporting the bridge has spherical bearings at the end of each leg and at the top of the arch. These bearings permit the arch to rise and fall as the towers move due to wind forces. Large longitudinal movements both towards and away from each tower are designed for. Allowance is made for up to 350 millimeters of movement each way, giving a safety factor of 1.25 in movement caused by the worst single storm in 50 years. A fail-safe design concept was implemented in the overall skybridge design for structural integrity. In the worst-case scenario, the main girders alone can stop the bridge from progressive collapse. The skybridge was fabricated and shop-assembled by Samsung Heavy Industries of South Korea, a world-leading steel fabricator. Samsung has also demonstrated its expertise and capabilities in constructing structural steelworks of many monumental and state-of-the-art high-rises worldwide. The fabrication took several months at 2 shipyards in South Korea. The box girder and legs were fabricated at Koje, the mainframe at Changwon. KLCC appointed the American Bureau of Shipping to closely monitor and inspect the process so that it is in compliance with the most stringent industry standards and codes, such as American Society for Testing and Materials, ASTM, British Standard, BS, American Welding Society, AWS, and American Institute of Steel Construction, AISC. The fully assembled bridge was then dismantled and the parts shipped to Kuala Lumpur. The components arrived at Port Klang on 3rd May 1995. The first components of the skybridge arrived at the KLCC site on 8th May. The assembly work started with the installation of shoring on the underside at the concourse level, down through the basement car parking levels, to prepare for the construction of an assembly bench for the bridge structure. Once the assembly bench was in place, the box girder, parts of the two main girders, cross-beam and horizontal braces were assembled progressively. Final inspections were made prior to assembly. The 307 parts of the frame for the center section of the Skybridge were fully assembled and bolted, and the floors were fitted in place. The center section of the Skybridge is then lifted 11 meters to allow for the upper 10 meters of the legs to be connected to the box girder. VSL Heavy Lifting, a specialist in this field, was appointed for the lifting of the Skybridge. VSL has vast experience in heavy lifting in buildings, bridge and energy projects worldwide. Among others, the company was involved in lifting a 5-acre roof of an aircraft hangar in Jakarta, Indonesia, the Olympic Indoor Stadium in Barcelona, Spain, and the Indoor Stadium in Istanbul, Turkey. Studies for the lift began more than a year ago and simulated various wind and weather conditions. Simulations were done to show the sequence of lifting the legs one at a time. Then the end block girder frames, and finally the center section. The actual lift starts with the installation of the spherical bearings to be located at the foot of each leg of level 29 on the 12th of June. The Skybridge legs were then lifted one at a time from 7th July, and the legs were temporarily supported by a tie to the columns at level 38. The lifting of the Skybridge end blocks followed on 10th July. The end blocks were then retracted a minimum of 100 millimeters into the tower to provide sufficient clearance for the Skybridge section during lifting. The center section is gradually lifted to its final level during an 18 to 20 hour operation and at minimum lifting speed of 12 meters per hour. At this stage, the legs can be lowered into place. The Skybridge will be completed in October 1995. With the completion of the Petronas Towers, the Skybridge will be an architectural wonder, seemingly suspended in mid-air. The lasting impression is one of a monumental gateway to the KLCC development and beyond.